Heat optimization. The heat energy is useful for many factors as electricity production. The main problem is that in most of the cases, this heat is dissipated or misused, leading to a loss of energy as a result. For this, the purpose of this project is the optimization of heat energy by focusing the heat produced naturally with the sunlight. Solar panels are the first one to come out when talking about exposure to sunlight. For this reason, this will be the main objective of the heat optimization project, but the photovoltaic cells aren't designed to support high temperatures, even though they are intended to expose to sunlight as much as possible. But, as mentioned in the book, Next Generation Photovoltaics, the next generation of photovoltaic cells will be focused on using the heat instead of being negatively affected by this, giving even more relevance to this project as these power cells will take the heat as a boost rather than a disadvantage. Focusing on the optimization of the heat, we must take in consideration any ideas that meant to do this in the past, just like the effect of a magnifying glass or a sun stove, who will be the center of attention for this research. This optimization also could replace the investment of many companies do in heat reflecting coatings that usually is applied to their panel cells. This because they could get damaged with time as they are exposed to high temperatures they are not designed to support. With the previous points established, the next step is to design an experiment to improve the optimization of heat. For this, we use the sun stove as a base and design an experiment that aims to find the best conditions where heat is properly used, as it is aimed to be easily recreated using home materials. The experiment will consist in the fabrication of sun stoves using containers with different shapes and coat them with aluminum film as neat as possible in order to obtain a surface as reflective as possible. Then, with a thermometer placed in the center of each container, measure periodically the ambient initial temperature and the temperature research after some time, 1 hour. Then repeat the experiment under different solar conditions at least 4 times in order to get an average, and see which are the conditions where the heat of sunlight is best optimized. As methodology, we will establish that, in order to obtain a reliable result, we must place each thermometer, the instrument to use in this experiment, with its tip in the center of each recipient, avoiding any contact with any surface. A paperclip is recommended. After each test, a photo of the container and the thermometer must be taken in order to ensure a good data collection. Neither the thermometer nor the container must be manipulated during the experiment time, otherwise the attempt will be discarded. Also, the data must be collected from both containers at the same time. The variables considered for this experiment will be the following: the container's shape as the independent variable and the heat increase as the dependent one. Also, as control variables, that both containers must have the same type of thermometer. Both containers must be set to the sun at the same time. The ambient temperatures must be taken immediately before starting each test attempt. Also, each attempt must last exactly 1 hour long. As control group, a test must be done by checking the ambient temperature and the temperature of the thermometer after 1 hour of exposition to sunlight without any container. And as test group, the container must have a regular geometrical shape and be coated aiming to the aluminum film as smooth as possible. The materials used for this experiment will be at least 2 geometrical different containers, aluminum film, scissors, scotch tape, a thermometer for each container, and a way to secure them to the center. A paperclip is recommended. Up next, we have the results of the experiment. In the following tables are shown the temperatures of the ambient and how each container affect in the resultant temperature, and in the colored graph we can see all the temperatures represented. The blue one is the ambient, the yellow the square container, and in the top the orange one being the cylindrical container temperature. With all this, we can conclude that, as expected, a cylindrical coating focuses more the heat. accomplishing the goal for the experiment, optimize the heat from the sunlight. After these results, we could take the experiment to a second phase, using the second generation cells and looking for the improvement with this heat optimization. Unfortunately, the solar panel must be small since they are quite expensive, but the results could be escalated to a bigger size and see how it behaves against a normal photovoltaic cells under the heat optimization conditions. Thank you all for your attention.